In this video, we're going to look at a study about the effects of sleep deprivation on learning. Kind of a triggering time in the semester to ask about this, I know. But you might be interested in whether you can actually function well the next day after a sleepless night. But what we're really going to focus on in this study is the recovery. So can you recover from a sleepless night by getting a full night's sleep on the following nights? This comes from an article in Neuroscience published in 2000. Someone was asking me the other day if these are real studies. Almost always they are. So in this study, 21 volunteers were trained on a visual discrimination task. So this is an example of a visual discrimination task where the picture on the screen would be flashed on the left, and then it would be quickly replaced by the one on the right, and then you'd be asked whether you had seen an L or a V, whether the slanted lines were placed vertically or horizontally. So basically you have to make judgments about the picture really quickly. So the way the study worked is they were randomly assigned basically half and half into a sleep deprivation group and an unrestricted sleep group. So on day one is when they did a pre-test and the visual discrimination training. So the goal of the training was to make them better at these visual discrimination tasks. And then night one, the night of the training, one group was deprived of sleep, the sleep deprivation group. On night two and night three, everybody had unrestricted sleep. So it's the idea that they would have a couple of days to recover. And then on day four, they took the post-test. And in this study, we're going to look at the improvement scores. So we're going to do post-test minus pre-test and see if those improvement scores tend to be higher for the unrestricted sleep group compared to the sleep deprivation group. Okay, so we're comparing two groups here. So this is our explanatory variable, is which treatment group they were in. This is categorical, and specifically it's binary. Everything in this chapter is going to be a binary explanatory variable, meaning that we're comparing two groups. And then the response variable was their improvement scores. So this was post-test minus pre-test, and that's a quantitative response. So this is different from what we did in chapters 5 and 8 because we're comparing groups on a quantitative response. So because it's quantitative, we're interested in the mean improvement scores for each group. So we're going to write our hypotheses in terms of mu, right? Remember, mu is like the population mean or the long run mean. So we can write this two ways. We can write it as the mean for the unrestricted is equal to the mean for the sleep deprived group. Or if we want to, we can write it as a difference. So we could do mu u, hard to say, minus mu d is equal to 0 for the null hypothesis. And we can also write this in words. So we can write it in terms of the long run means. So we could say that the long run mean improvement scores, that's the response variable here. The long run mean improvement scores are equal in both groups. Right, meaning that it doesn't really make a difference whether you're in the unrestricted sleep group or the sleep deprived group. Your improvement scores are going to be the same on average. We could also write this in terms of an association. So the null hypothesis would be no association. And remember, when you say association, you mean association between the variables, not between the groups. So here we would say no association between the sleep condition, so whether they were unrestricted or deprived, and improvement. So those are all different ways of writing the null hypothesis, all ways of saying the same thing. And then the alternative, again, we could write this in terms of mu u and mu d, just comparing them directly. And I didn't really do a good job here of stating the question. It's hard to tell what the assumption is going in, but I know just for me personally, I would assume that if anything, unrestricted sleep is better for your learning than sleep deprivation. It's hard for me to imagine going the other way. So I should have done a better job of writing out the statistical question, but I think I'm going to use greater than as my alternative hypothesis. And I could also write that as a difference again. The difference is greater than 0. And I'm not going to write it in words. I think it's pretty clear how this would transfer. The long run mean improvement score is higher for the unrestricted than the sleep deprived, and that there's a positive association between unrestricted sleep and improvement scores. So we're going to look at the ISI applet for multiple means. And this is actually the data set that's automatically loaded here. So we've got unrestricted and sleep deprived. You can also add the box plots if you want to. So that makes it a little bit easier to see. If you look at the box going up, that's like 75%. So you can see that the top 75% of the unrestricted is higher than the lowest 75% of the sleep deprived. So we've got a good bit of separation in these data sets. This will also calculate for us the means and the standard deviation. So we can see that the mean for the unrestricted sleep group was 19.82. The mean for the sleep deprived group was 3.9. So in a simulation-based test, we start with a statistic, and this needs to be one number that we can calculate from the sample that will summarize the strength of evidence. So here I'm going to do a difference of sample means. So I'll do the mean for the unrestricted minus the mean for the deprived. And I like to do it where the numbers will be positive, but you could technically set it up either way. So we've got 19.82 minus 3.90, and we get a difference of 15.92. So on average, the unrestricted sleep group had improvement scores that were 15.92 points higher. So is that enough to be convincing? Or is it possible that 15.92 could have occurred just by chance, right? That they ended up unbalanced when they did the random assignment just by random chance. So to figure that out, we're going to do a simulation. And we're going to have to adjust this a little bit from the way we did simulations for categorical data. So with categorical data, we would use like two colors of cards to represent the successes and failures. But here, we're wanting to record a quantitative value, not just whether it was a success or a failure. So instead of using colored cards, we're just going to use blank cards, whatever color you want, and we're going to record the response variable. So here, we're going to write the improvement scores on cards. So notice we're still representing the response, which is what we did when we were dealing with categorical data. It's just now the response is quantitative. But the next parts are the same. We're going to shuffle everything together. No need to label them based on whether it's deprived or unrestricted, because we're assuming at this point that it doesn't make a difference, right? That there's actually no difference in the means for these two groups. Then we're going to simulate the random assignment by dealing into two groups. And we want our sample sizes to match the original sample. So we'll have a sample size of 11 for the first group and a sample size of 10 for the second group. Then we're going to calculate a statistic. It needs to be the same one that we used before. So we're going to calculate, in this case, the difference of means, x bar u minus x bar d. So that's to summarize the simulated sample, and then we're going to repeat. And the applet's going to do this for us. I like to look at the plot here. I find this very satisfying. So it shuffles up all of our responses and it re-deals them out into groups. And then it's calculating the mean for each of these groups. And then the difference here is negative 1.4, and that's what gets plotted. I don't know why I think that's like so adorable. We got, what, 4.62 gets plotted there, 2.35, and then obviously we can do a bunch more of these. So 9997. Okay, so we have our simulated distribution here. Take just a second, pause the video, and decide what you would conclude. So it's centered at 0 because of the null hypothesis, because we assumed that there was no difference between these groups. So the fact that it's centered at 0 doesn't tell you anything on its own. The way we're going to use this distribution is we're going to find our sample statistic, which in this case was 15.92, and see how extreme it is. So we're finding it and counting how many are there or more extreme. So out of these 10,000 that I've simulated, I've got 71 that are at 15.92 or more extreme. So that's a pretty small p-value, 0.0071. So we found our difference in means, and we shaded everything here or more extreme, and that gave us our p-value, 0.0071. So if there were really no difference in means, getting a value like ours would be pretty unusual. So this is going to give us very strong evidence against the null and for the alternative. So in this case, we would say very strong evidence that sleep deprivation causes, and I'm using causal language, but that's okay because this is a randomized experiment, that sleep deprivation causes the improvement scores to be lower on average. So of course this isn't a perfect relationship. We don't expect every single person in the sleep-deprived group to have a lower score than the unrestricted, but we have strong evidence that on average, sleep deprivation does have an effect on the scores. And remember, this is even after they've had a couple of days to recover. So if there's a takeaway from this, it's that sacrificing sleep in favor of studying a lot of times does backfire. I give that advice all the time and nobody ever believes me, but it's super good advice. The new information you learn may be worth less than the mental capacity you lose. Okay, so we have strong evidence that sleep deprivation makes a difference. How big of a difference? What's the impact of this sleep deprivation on improvement scores? So to do that, we're going to use the 2SE method to find the confidence interval. And it has the same general format we've seen over and over, a statistic plus or minus a multiplier times the standard error of the statistic. So our statistic here is a difference of means, so 15.92. This is just a 2SE interval, so we're just using a 2 for our multiplier. And then for the standard error of the statistic, for now we're just going to use the one from the simulation. So remember, the standard deviation of the statistic, this is a null distribution where every dot is a statistic. So this standard error of the statistic is basically saying how much do we expect those statistics to vary from sample to sample. Okay, so I'm going to plug in that number, 6.700, and I end up with a confidence interval of 2.52 up to 29.32. So this is actually a pretty huge interval. If we look at the scale of the scores, it really only went from, I don't know, maybe -20 to 40 or something like that. And so this interval is really big. We don't have a very precise estimate, which makes sense because our sample size is so small here. With only 10 or 11 people in each group, it's really hard to come up with a precise estimate of the effect size. So kind of like we saw in previous chapters, there's more than one way to interpret this interval. One is to do just sort of a basic, we're 95% confident that our parameter is in the interval. So in this case, we're 95% confident that the true difference in mean improvement scores, because that's our parameter that we're trying to estimate. We're 95% confident that the true difference in mean improvement scores. And if we're going to write it this way, we do need to specify which way we're subtracting. So in this case, it would be unrestricted minus deprived. So the true difference, unrestricted minus deprived, is between these values, is between 2.52 and 29.32. So we have a very explicit statement of what our parameter is. It's the true difference in means, and we're being specific about the direction, that unrestricted minus deprived is positive, meaning that the unrestricted values are higher on average. Or the other way we could write it kind of incorporates the causal language a little bit more. So we could say we are 95% confident, starting the same way. Remember, 2SE intervals always correspond to 95% confidence. We're 95% confident that sleep deprivation, and obviously we're talking about the specifics of this study, so sleep deprivation followed by 2 nights of recovery, that sleep deprivation causes the improvement scores to be this much lower, to be 2.52 to 29.32 points lower on average. So to me, it was easier to think about unrestricted sleep as like the baseline group and then comparing sleep deprivation to that. You can phrase it either way you want to, as long as it's really clear that you're comparing means. So I've got that on average part to make it clear I'm comparing means, and also that it's clear which group is higher on average. So that's a simulation-based approach to test for significance and estimate the size of the effect.